Welcome to the deep dive. We are jumping straight into a really fascinating piece of source material today.
Yeah, we've got a personal journal entry from a developer named Ang,
Right. It's titled Notes on Haskell Programming, Part 125.
which I know sounds intensely specific.
It does. I mean, on the surface, Ang's post is this highly technical log about debugging a multi-line paragraph parser.
But our mission today is actually much broader than just a single code fix.
Exactly. We're using Ang's journal to explore how the structural design of the languages we use, whether you're writing functional code or, drafting a legal contract, or even just building a team workflow.
Right, how that structure fundamentally shapes the way our brains actually process logic.
So, to get into the mindset of this specific bug, I want you to imagine for a second that you are sitting down with a dense, complex novel.
Okay, I'm with you.
You're completely engrossed, you're tracing the narrative logic, and then your eyes hit the edge of the physical page.
Right, the text wraps to the next line.
Yeah, it wraps, but instead of continuing the sentence seamlessly, your brain suddenly just hard resets.
Oh, wow.
Yeah, it treats that new physical line of text as a completely new, entirely unrelated thought.
That would be cognitive chaos.
Yeah.
I mean, you wouldn't be able to assemble a single cohesive idea.
No, not at all.
Because your processing engine would just fracture the narrative every single time it encountered a visual formatting break.
Okay, let's unpack this. Because while it sounds totally absurd for a human being to read that way, when you step into the world of compilers and syntax trees, that kind of rigid, literal interpretation is, well, it's a constant hazard.
It really is. And for you listening, even if you have absolutely zero programming experience, I promise this is relevant to you.
Oh, definitely.
Because bridging the gap between how our human brains naturally build context and how a machine demands we structure explicit logic, that's the core of Ang's dilemma here, and it will change how you think about organizing your own thoughts.
Syntactic structure dictates cognitive load.
Exactly.
Yep.
We're going to look at how we communicate complex pipelines of thought, where those pipelines break down between human and machine.
Right, and how subtle architectural choices in a language actually change the very philosophy of problem solving.
But we have to start with the real-world problem Ang was trying to solve, right? Before we can analyze the elegance of the code.
Right, so Ang was testing a system that generates PDF documents using TIPST.
Which is a modern alternative to LaTeX for typesetting, for those who might not know.
Right, exactly. And specifically, they were working with a template designed for Chinese text. So they were feeding text files into this system, and the paragraph parser was supposed to identify block boundaries to format the final PDF correctly.
And typesetting engines are incredibly unforgiving when it comes to parsing boundaries.
Oh, so?
Well, in Western languages, you have clear word spacing, right? And capitalization rules.
Sure, capital letters at the start of a sentence.
Exactly. Those offer secondary cues for sentence and paragraph structures. But CJK, Chinese, Japanese, and Korean typesetting often just doesn't rely on those same spacing delimiters.
Oh, interesting.
So the parser's logic for determining where a discrete thought begins and ends carries a ton of weight.
And the issue Ang ran into during testing was pretty catastrophic for the document's formatting.
Yeah, it was butchering the multi-line text.
Right. It was treating every single individual line as its own separate, isolated paragraph block.
Because the parser was reading a continuous data stream, right?
Yeah.
It hits an EOL, or end-of-line marker.
Just a standard new line character.
Yeah. And it immediately terminates the node in the abstract syntax tree. It essentially just says, I found a break, I'm closing this object, and whatever comes next is a brand new object.
I struggle to understand why a parser would be architected that way in the first place.
It seems counterintuitive, right?
It really does. We intuitively understand that a paragraph is a group of related sentences. Designing a system that assumes a single line equals a paragraph seems, fundamentally flawed.
It misses the entire context of human writing.
Exactly. Why build a parser so short-sighted?
What's fascinating here is that the machine isn't being short-sighted at all.
It's not.
No, it is being strictly obedient to its grammar definitions. Parsers don't possess intuition,
Right, they're just following rules.
Exactly. They build trees based on explicit terminal and non-terminal symbols. In a lot of lightweight markup languages, a single new line character is just the cheapest, most computationally efficient boundary to check for.
Because human language relies on implied context.
Yes, tone, narrative flow, thematic continuity, We wrap text on a screen purely for visual convenience.
But the machine sees that visual convenience, the new line character, as a literal instruction.
Unless it's explicitly told otherwise.
So Aang had to rewrite the parser logic to essentially teach the machine how to ignore its own literalness.
Which is a brilliant way to put it.
Yeah. Instead of just stopping at that single new line, Aang shifted the entire paradigm. The updated logic captured the first line and then instituted a look-ahead function for the other lines.
Right, redefining a paragraph to the computer by defining what it isn't.
Exactly. The new rules basically stated that a paragraph is a sequence of lines that are not separated by a blank line and do not start with a header pattern.
And shifting from a positive trigger to a negative conditional is a massive leap in parser sophistication.
Because it changes the default behavior.
Exactly. A positive trigger says, stop when you see X. A negative conditional says, keep going, keep consuming data unless you see X or Y.
So it forces the parser to hold the current state open.
Yes, it's constantly peeking ahead at the next token in the bucker before it decides whether to actually close the paragraph node.
Fixing that parser required writing some incredibly dense logic.
Oh yeah?
But Aang's journal entry doesn't just celebrate fixing the bug. It actually pivots into this deep appreciation for how that new logic was organized.
Yeah, Aang had an epiphany about the architectural beauty of Haskell.
Right. Aang spends a significant portion of this entry just praising Haskell's where keyword.
So Haskell is a purely functional programming language,
Yeah.
which means it behaves very differently from imperative languages like Python or C++men.
Right.
In an imperative language, you are giving the computer a step-by-step list of instructions, constantly changing the state of variables.
Do this, then change that.
Exactly. But Haskell is declarative. You don't tell the computer how to do things step by step.
You declare what things are.
Mathematically, yes.
And the where keyword is the syntactic tool that actually enables this declarative philosophy. Aang lays out exactly how this looks in the code base.
It's a really specific structure.
Yeah, you write your main function at the very top. This is what it tells the high-level story of the code's objective.
The goal.
Right. Then, immediately below that, you drop the where keyword, and underneath that, you nest all the messy implementation details, the helper functions, the how.
It mandates a top-down design pattern. You're declaring the ultimate outcome first, and then defining the constituent parts that make up that outcome in a deferred block.
So what does this all mean? To me, this structure mirrors how we read a massive corporate business report.
Oh, that's a great analogy.
You don't open page 1 and start staring at raw data tables and granular analytics. You start with the executive summary.
You read the what first?
Right, the profit margins, the core strategy, and if you need to understand the mechanics of how the team arrived at those numbers.
You go to the appendix at the back.
Exactly. The where clause is essentially a structural requirement to put the appendix at the end of the file where it belongs.
The separation of concerns is built directly into the grammar of the language itself.
It forces you to be organized?
Yeah, when you open a Haskell file, the syntax forces you to encounter the author's primary intent before you're ever exposed to the mechanical execution.
And I have a question about this. Does separating the what from the how actually change the compiled software? Because Aang notes that this syntactic flavor is incredibly rare. Like the closest equivalents are let bindings or maybe Elixir's private functions, the def stuff.
Right.
If we are just moving the helper functions to the bottom of the screen instead of the top, does it actually make the program run faster? Or is this purely psychological trickery designed to make the human reader feel better?
If we connect this to the bigger picture of software engineering, we have to acknowledge that code is read far more frequently than it is written.
That's very true.
The compilation process, turning that Haskell code into actual machine instructions, it doesn't care whether you use a where block at the bottom or a let expression at the top.
The machine doesn't care about the aesthetic.
Exactly. The resulting abstract syntax tree will likely optimize down to the exact same bytecode.
So the performance is identical.
Identical. The psychological trickery is entirely the point.
Because the bottleneck isn't the machine's processing speed at all. It's the human's cognitive load.
We talk about cognitive load in terms of working memory. A human can really only hold a few chunks of abstract information in their head at one time.
Right.
If I force you to read 3 complex helper functions before I ever show you how they combine into a final result, you have to hold those 3 abstract concepts in your working memory without any context for why they even exist.
That sounds exhausting.
It is. The where clause reverses that. It gives you the context first. You know the goal. So when you read the helper functions, your brain instantly maps them to an established framework.
So the language is actually acting as a strict editor, basically forcing developers to be better communicators.
Exactly.
But even with a brilliant top-down framework, reading the individual lines of Haskell can still induce mental whiplash.
Oh, absolutely. Line by line, it can get rough.
Ang points to a specific line of code written before the final refactor, and it reads like this. Subsequent line equals many $, try open parenthesis, eel, asterisk, arrow, not followed by stop sign, asterisk, arrow line, close parenthesis.
Yeah, that's the dense string of parser combinators.
Ang literally refers to it as alphabet soup. And the main culprit causing the cognitive friction in that specific line is the $ symbol.
Yes.
Ang asks the journal reader, should you read this from left to right or right to left?
Which is a valid question in Haskell.
Because in Haskell, that $ operator acts as a set of invisible parentheses, right?
Yeah.
Forcing the compiler to evaluate the entire right side of the expression first.
Right. So function application in Haskell has the highest precedence. If you string multiple functions together without parentheses, the compiler just gets confused about what applies to what.
It needs order.
Yeah. And the $ is an operator with the absolute lowest precedence. It effectively says, evaluate everything to my right before you feed it to the function on my left.
Here's where it gets really interesting. Because of that mechanism, the human brain reading the code is forced into a state of what Ang calls directional ping-pong.
Directional ping-pong.
You start reading left to right to identify the variable, then your eyes must jump all the way past the $ to the end of the line to figure out the core parser logic.
And then you work your way backward.
Yes. It reminds me of Yoda from Star Wars. Evaluate the right side first, you must.
Yeah, exactly like Yoda.
Mm-hmm.
You know, the LISP programming language notoriously suffers from the opposite problem.
Oh, deeply nested parentheses.
Exactly. You end up with 5 or 6 closing parentheses at the end of a line, which is just incredibly visually noisy.
Right.
The $ was designed to eliminate that visual noise.
But we all read left to right. I mean, human languages, at least the ones the language designers were speaking, flow sequentially. Why intentionally design an operator that forces a human to play directional ping-pong?
It seems counterproductive.
It feels entirely counterintuitive to the empathy we literally just praised the where clause for having.
This raises an important question about the fundamental tension between linguistic intuition and mathematical reality.
Okay, say more about that.
A programming language is really just a translation layer between two completely distinct domains. Human linguistics relies on sequential chronological storytelling.
Beginning, middle, end.
Right. But the machine's native processing is rooted in pure mathematics and function composition.
And mathematics doesn't prioritize left to right sequencing.
Not at all. Take algebra.
Yeah.
If you evaluate f of g of x, you cannot start with f.
Right, you have to know what x is first.
Exactly. You must resolve x, pass it to g, and then take that entire result and pass it to f. You are working from the inside out, or right to left.
So the $ operator perfectly aligns with how a compiler constructs its mathematical syntax tree.
Yes, it is mathematically elegant, even if it completely violates our linguistic habits.
Okay, so to fix the ping-pong effect, Ang actually started experimenting with a different operator, the ampersand.
Ah, yes.
This is a reverse application operator. By replacing the $ with the ampersand, Ang reversed the flow, allowing the logic to be written and read left to right.
So the data goes in on the left, and it pipes through the function sequentially.
Exactly. Ang is even debating adopting this ampersand across the entire project just to reduce mental fatigue.
The ampersand or pipeline operator, which is actually highly popular in languages like F# or Elixir, is a really fascinating compromise.
Because it bridges the gap.
Yeah, it is a mathematical function that explicitly caters to human linguistics. It tells the compiler, take the value on the left and apply it to the function on the right.
So it reads more naturally.
It allows the developer to write code that reads like a sentence. Like, take this data, then parse the line, then check for a stop sign.
It's a negotiation between two competing architectures.
Beautifully put.
We want to talk to the machine sequentially, but the machine's native engine needs nested evaluation. So we invent these syntactic sugars, like the ampersand, to mask the mathematics behind a veneer of human storytelling.
And developers obsess over these micro decisions because that cognitive overhead, it compounds over time.
Oh, I bet.
When you are debugging a complex PDF parser, the difference between reading a pipeline left to right versus mentally unraveling a right to left evaluation tree That can literally be the difference between solving the bug in an hour versus staring at the screen all day.
Syntactic elegance.
Yeah.
Whether you are architecting a massive code base in Haskell or, drafting a complicated project proposal or designing a standard operating procedure for your team, syntactic elegance dictates your success.
It applies everywhere.
It really does. How you structure your information dictates how effectively your logic will be executed by whoever or whatever is reading it.
Form and function cannot be separated. The medium really is the message.
Right.
If you obscure your what behind your how, or if you force your team to play directional ping-pong to understand a workflow, the logic will fracture. Just like the parser misinterpreting that new line character.
You have to utilize your own version of the where clause, put the intent up front, keep the mechanics in the background.
Streamline it.
Streamline the flow of information so that the logic cascades naturally, rather than forcing the reader to constantly switch contexts and trace their way backward.
We've spent this entire time analyzing Eng's strategies for making complex logic readable for the human brain.
Yeah.
The where clause, the debate between the $ and the ampersand, these are all tools designed to protect human cognitive load. But I want you to consider where this is all heading.
What do you mean?
We are accelerating into an era where artificial intelligence agents are writing, reading, and refactoring massive code bases completely autonomously.
And AI models don't experience cognitive fatigue.
Exactly. An AI doesn't need an executive summary to understand the context of a file. It doesn't get mental whiplash from reading right to left.
It just reads the math.
It can parse mathematical alphabet soup and deeply nested syntax trees infinitely faster than a human brain can process a simple left to right sentence.
Wow. So if the primary reader of our logic systems is no longer human, the rule of syntactic elegance change entirely.
That's the thought I want to leave you with. In 10 years, will human-centric code structure even matter?
That's a wild thought.
Or will the languages we use to build our systems become entirely alien hyper-optimized pipelines designed purely for machine-to-machine communication? We might look back at beautiful, empathetic concepts like the where clause as nothing more than historical artifacts from time when humans still needed to read the instructions.